from the Department of Industrial Technology, especially student the Mechanical Engineering Education Program, Electrical Engineering Education Program, and also Electric System Engineering Program. I want to tell you, we are one of the 8 faculty of National University of Education, where we are classified as a young faculty with a lot of young people who want to develop and want to know many include some of the topics you have prepared, which you will share with us. And beyond, I think this event is very, very important for us to listen together to increase scientific knowledge as well as know the global research development in mechanical, electrical, and electric system engineering in the future. Ladies and gentlemen, allow me openly say greeting in Bahasa. Om Swastiastu, wassalamualaikum warahmatullahi wabarakatuh. Salam namo budaya, salam kebajikan, salam harmoni. Selamat datang adik-adik mahasiswa pendidikan teknik, pendidikan elektro dan elektronika, sistem elektronika. Sudah datang pada kegiatan. Jadi, this day of the Faculty of Fakultas Teknik Komputer dan presentasi nah itu dah kemarin sudah dia kemarin dia sudah ready mungkin dia kisah. Thank you for coming, coordinator of study program of the Faculty of Vocational Engineering. Thank you for coming. All lecture of the Faculty of Vocational Engineering. And the last, thank you students, all students, for being in this course. We conduct this activity to provide scientific insight on several matters in accordance with the above topic for lecture and student. We will continue to do this activity often to increase our knowledge in our scientific field. I hope we will be able to continue to cooperate for several other activities in the future between NTU and UNISA. Once again, Mr. P, thank you very much for coming.
Yeah, thank you.
Thank you for spending your time visit in our campus. I hope this event has benefit for all of us. Thank you for all. Om Santi 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 Om. Assalamualaikum warahmatullahi wabarakatuh. Salam harmoni. Thank you.
Thank you to Mr. Hendra for this remark. Next, maybe kindly, Mr. Professor Jong-Min, you could give us a few words.
Thank you. Okay. Thank you very much. So first, people, I would like to thank invitation by the team and then also is the Miss Novia. Okay, thank you very much for your arrangement and then for the the information. Okay, so it's thank you very much for everyone. It's a very pleasure to meet you and then share some information. Actually, the last minute is actually I prepared some slide for the sharing that is I involved some areas and then some information. So I heard that this is the year 1 and year 2 students in engineering, especially the mechanical and electrical engineering. So I just collect some the slide that is probably useful. Is not only just my research, but it's more is the academic point of view in the some aspect and then some information. So is the I will try to share some information. Hopefully that is useful for your future as well. Okay, thank you.
Thank you, Professor Lee. Once again, it is such an honor to have you with us today and and giving a lecture to us for 3 days ahead and also discussion. And for our token of appreciation, we have a small gift from our department to Professor Lee Jong-Min. Maybe Pak Dekan, Mr. Prihendra could give this small gift to Professor Lee Jong-Min.
Yeah.
Yeah.
Okay. Thank you.
Thank you. Thank you very much. Thank you.
Okay, with the presentation of this woman Prof, then our welcoming ceremony comes to end. Thank you for Bapak Dekan and juga Bapak Wakil Dekan dan Ibu Wakil Dekan for coming. If you have another agenda, please feel free to proceed with your other engagement. So, ladies and gentlemen, next we're going to have a lecture from Professor Lee Jong-Min on meso porous material in mechanical and electrical field. Professor Lee, the time is all yours.
Thank you.
So we will leave this room. This
Okay,
will be your
okay.
classroom for the next 3 days.
Okay, thank
And
you.
Your students.
Okay, thank you very much.
Make a good classroom.
Okay, thank you.
Yeah.
Yeah, thank you. Thank you very much.
Thank you for
Yeah, thank you.
your
Okay,
presentation.
okay, thank you. Thank you.
You can use a slide.
Uh-huh.
Also prepare a whiteboard for you. So anything.
Yeah,
one
slide
you
is okay. Yeah, thank you.
Do you use okay?
Yeah. Now it's working. Working. Oh, this one. Huh? Display.
Firstly, I would like to condition the class first before I speak. If that's okay. Yeah. Okay. Okay, selamat pagi semua adik-adik mahasiswa. Bapak dosen yang juga sudah hadir pada kesempatan ini, terima kasih ya. Jadi dalam 3 hari ke depan kita akan ada series of lecture gitu ya. Jadi kita akan bicarakan 3 topik yang berbeda ya. Sesuai perencanaan hari ini
kedua kita akan bicara tentang aerodinamik, ya.
Now working.
Yang ketiga kita ada tentang conception government, ya. Nah, saya harap di 3 hari ini semuanya tetap bisa hadir dari mahasiswa, ya. Dan ini pun adalah sudah diwajibkan gitu ya menjadi kuliah mengganti pada minggu ini gitu ya. Jadi teman-teman yang belum hadir silakan di depan, ya, boleh semuanya lagi. Jadi silakan ikuti perkuliahan ini sama seperti perkuliahan kita di kelas ya. Cuma karena kita tamunya dari luar, jadi kita lebih disiplin lah sedikit. Oke, dan ini kesempatan yang mungkin tidak bisa kita dapatkan setiap hari, jadi gunakan sebaik-baiknya. Perhatikan materialnya. Jika ada yang ingin kalian tanyakan pertanyaan apapun, jangan takut. Kalau misalnya bingung bahasa Inggrisnya, nggak apa-apa pakai bahasa Indonesia dulu, nanti kita bantu translate bisa kita gitu ya. Oke, paham semua? Paham. Mari kita ikuti pilihan dengan baik ya.
Yeah, thank you. Okay, before we start, I will share some information. You are actually year 1 and year 2 students, so it's maybe I guess some of you is maybe interested in the graduate study, and then also is maybe overseas. So I will share some of our department, and then some information about our research area and topics, and then also faculty as well. So I will share some slides, and also history. So it's actually the Nanotechnology University this is about a little bit background. It's starting with the Yunnan Garden campus. That is the first campus is built back in the quite long time, and then this is the main campus, and then this is a little bit about next is about. So this is the second campus we call is the NTU One North campus. And then this one is actually for the graduate study. There is actually we have also some other campus as well in the Biopolis and then Fusion Police as well. And then we have actually collaborated with some other universities and institutes and agents as well. And then we have doing some CREATE program that is from the Singapore government collaboration project between the NTU and also is the overseas university. And then this is a little bit about the history about the NTU. Was established around 1955, and then is considered as the first Chinese medium university outside of Beijing, China. And then is the 1981 is NTU Institute was set up with 3 engineering schools, was very small in capacity. And then 1991 is the NTU was set up with actually including the National Institute of the Education. And then is the 2005 is actually it was the considered as a 50th anniversary with set up with the new schools, art and design and media, and humanities and social science, and also it's a physical and mathematical sciences. And then is 2007 is the formation of the college structure. In the previous we have the individual department, but later we form the college structure. So there is we have a College of the Engineering, College of the Business, College of the Science, and College of the Humanity, Art, and Social Science. So this is the basic old the college structure. So in the College of the Engineering we have the 6 schools. So chemical and biomedical engineering. Now we actually combined some other schools, and then civil and environmental engineering and computer engineering and electrical and electronic engineering, material science and engineering, and mechanical and aerospace engineering. And College of the Science is 2 schools, biological science and physical and mathematical science. And College of the Humanity, Art, and Social Science is we have 3 schools. One is Art, Design, and Media, and Humanity and Social Science, and Wikimedia School of the Communication and Information. We have also College of the Business, and also we have a School of Medicine, and also is the IGS, it's an interdisciplinary graduate school. And also is we have the education program, which is the National Institute of the Education. And also is we have the School of the International Studies. And then is the NTU, this is about research intensive university. Is actually is previously is this one is the only just we mainly is focusing on the teaching, but it's later back to 20 years, and then is start the focusing on the research, and then is the time high world ranking is the now. It was this one is 10 years ago. Is the ranking is about now is I don't know it's around 40 something, and the QS ranking is around 10 or 12 in the range, and then it's College of Engineering is one of the largest college, including the 6 schools. And then it's this one is also is the we haven't the update yet. It was quite the long time. Is we made a slide. Actually, the chemical engineering program is one of the in the 12, 12 around the 12 years ago was 30. Now it's around the ranking in the world is around the 5. So it's it changed a lot. And then is the we have 2 divisions. Is currently is one is the chemical and biomolecular engineering, and then bioengineering. And then is academic staff around 40, and then is research staff around 110, and then PhD student is around 200, and then is undergraduate student is around 100, 1,100, and then is we have the 2 excellent the research center, which is the one is advanced bioanalysis system, nanosystem, and the biotechnology. And then research funding is the average yearly around 10 million Singapore dollars. And then is the PhD study is this is basic background. So then is the chemical and biomolecular is a key engineering aspect, and then it's a study, and then Singapore worldwide, and then it's pharmaceutical and chemical companies that is involved in all the basic science. And also is we have the bioengineering, and then it's multidisciplinary approach for the development of the processes. And then this is a research area that is we involve the actually our faculties, and then synthetic biology is around the 6 faculties involved, and then it's tissue engineering and regenerative medicine is 9 faculties, and biosensors and devices around the 6 faculties, and catalysis and chemical system engineering around the 9 faculties, and then nanotechnology and printed devices is 8 faculties involved. And then this is the laboratory and facilities that you can see that I think it's some of them is Raman, and then NMR, and then it's SEM, and then all the essential the equipment is in our school. So that is our school is the researchers and PhD students, and also some master students can access and they use this equipment for the characterize the materials. So it's yeah. And then it's this is our school, and then it's thank you for the attention, and then this is the basic information. So if you are interested in the graduate school in the future, then you can search the NTU website. That is the actually the portals that is you can apply for your application for the study. Okay, right. Thank you for this. I close this one? Oh, sure. So this one. Yeah, yeah. No, 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 no. Oh, yeah. This one is okay. Oh, no, no. Yeah, yeah. Huh? Have to. Bigger size. Oh, okay. Now is I move on to the some information about the materials. So is Ms. Nobia mentioned about some mass produced material, but it's the general materials. So it's the year one and year two student is maybe interested in the maybe more is background, and then it's also it's some peoples, and then it's some different aspects. So it's I try to collect some slide for your information. So that is hopefully this is the some good introduction about the materials. So it's in engineering is actually is defined as the engineers is a application of the physical science together with the principles of the economics and human relations to the field that is contain the directed processes and process equipments. And the matter is treated that change in the state energy contents and composition. And actually, is when we talk about the materials, is generally is the major materials is comes from the chemical engineers. So it's, I will just introduce some of the chemical engineering background and also is some important information here. So it's chemical engineering is the development of the processes and design and operation of plants, and then materials go changing their physical and also its chemical states, as you know, and applied through the process industry is found on the principle of chemistry and physics and mathematics is all the involved. And then it's chemical engineering in the field of the applied science that is actually employs the physical, chemical, and biological processes for the betterment of the humanity is by the modern. And then it's the history of the engineering is this is quite long time ago. It's not historically is defined yet, but it's the application of the processes that has been existed for centuries, a long time. And then it's the process of the fermentation. This is the actually the mention in the Bible and also is the Homer. However, the discipline of the engineering by the union of principle of chemistry and mechanical design of equipments for industrial application for large-scale production of the essential chemicals. And then George Davis is the English consultant, and then he's having the point terms is the chemical engineering. So it's David is defined the broad the features in the common all the chemical factories, and then wrote the influence of the handbook of chemical engineering based on the chemical factories, and then also is around the Manchester, England. So engineering for today is play important role in many industries. Is serving the professions in the which chemistry or biology factor, including the semiconductors, nanotechnology, and food agriculture, and then it's environmental control, pharmaceutics, and also it's energy, personal care products, finance, medicine, and so on, and traditional chemical and petrochemicals. So actually, the engineers is actually spend a lot of time for following is nowadays is 14 actually the areas. So is the first one is important. Probably when you consider take a job, then it's probably following the 14 the industrial area will be very important. So there is engineers is try to make a solar energy economical, and then it's provide the energy from the fusion, and then also is to provide the access to clean water, and is four is a reverse engineer the brain. No seat, I think. Okay. And then is the five is advanced personalized learning, and is six is develop the carbon sequestration method, and then is seven is the engineer tools of the scientific discovery, and then is eight is restore the important urban infrastructure. Nine is advanced health informatics, and then 10 is prevent the nuclear terror. 11 is engineer better medicine, and 12 is enhance the virtual is reality. 13 is manage the nitrogen cycle, and then 14 is a secure cyberspace. So next is I'll introduce some of the pioneers in engineering that who developed the important materials. Probably some of terms that is you may heard about before. So I'll introduce some of them. So it's the first one is actually the Andrew Grove is actually he's the chemical engineer who was one of the three founders of the Intel Corporation. So it's you know the Intel Corporation, right? So it's all the computers and then it's iPad, all the important chips is made from the Intel. So he's the Intel actually the CEO for many years, and then selected as the Man of the Year in the Time magazine in 1997. And then the next one is the Allen is Michaels. He's a pioneer for the thermal is a drug delivery. Probably you heard about the patch. So it's the patch is actually he built actually the ARZA is the research company that he was the president in 1970, and then developed various the drug delivery devices, including the transdermal is a delivery is known as the patch. So he's the pioneer in this area. And then the third one is the J. Kisling. He's the professor in the University of California at Berkeley. And then he's the pioneer in the synthetic biology, especially, and then construct and inexpensive synthetic biology routes. And then the component that is the medication of the choice for is combating malaria is to resistance to something that is chemical and derivatives. And then his fourth is the nanotechnology is the Michael Strano. He's the professor in the MIT, and then he developed the chemical sensors, and then the sensor is reduced to very small molecular dimensions and become the possible to detect even single unenlightened molecule. So he's the pioneer the use of the carbon nanotube to create the nanochannel. Only permit the passage of the ions with a positive charge is enabling the observation of the individual ions in the water at the room temperature. And also is very pioneer is the Matteo is the Pascual, and then he actually is find a way to process this carbon nanotube, produce the high the strength fibers that is electrically is conductive. Such a fibers is could reduce the weight of the airplane panel. And then it's also is there is another person that is David Sohn, and then is he also is the actually is developed the nano hair process, and then he actually developed the cotton the fibers, and then this one is very light and it's very useful, and then upon the heating the water evaporate, and then it's nano the whiskers is the bond is permanently to cotton fibers. And then it's the polymer materials is developed by the probably you heard about it, is a Gore-Tex the materials for the clothes. So he is actually the pioneer for polymer material is the Robert Gort. So actually is he actually is developed something the new materials in the polymeric material that is actually made from the porous material from the poly PT Fe, actually known by the Teflon, and then in this case is actually it passes the air and the water vapor through the small pores to make a mass porous film and also channel. However, it does not permit the passage of the liquid water because of the hydrophobic of PTFE surface. So he's having the ideas, so that he's developing the new materials for our clothes as well in the nowadays. So it's another person is Alice the Gasser is actually she's a pioneer. She's a pioneer in the colloidal science. And then she's the president. She was the president of the Lehigh University. And then actually they try to find how the interaction between the colloidal forces and electrical field is determine the magnitude of the electrorheology response. And then there is also the pioneer in the tissue engineering, which is the Christie, and then Assoc is actually tissue engineering is popular in the field in the restoring and replacing the organ functions by constructing the biocompatible scaffold on the cell can growth and differentiate. So she is a pioneer in the tissue engineering. And then it's also the important area is the water desalination part, and then it's a pioneer is actually is Sydney Lopes, and then it's Srinivas is Sri Rajan. Actually is in this process is the membrane is commonly is used in many areas, including the hemodialysis and oxygen enrichment. And then they try to develop the reverse osmosis process for water desalination. It's around back into 1959. And then next is the fuel cell. So it's a fuel cell is also the important area that is people try to develop nowadays still. And then is developing the pure cell technology and implementation. However, it's still now we have some drawbacks and the limitations. So this we cannot actually having the commercial is common the pure cells yet. So this is about the materials in the world. Now we can split into the category into the four. Basically when we talk about the raw materials, that is including the oil, natural gas, and coal, and biomass, rock, and salt, sulfur, and etc. All the elements and water. And then it's the major fuels. Is when we talk about the major fuels, then is including the LPG, gasoline, and diesel, and kerosene. And then when we talk about the bulk material, that is including the base chemicals and intermediates. And then 4 is a special chemicals is made from the bulk chemicals. So it's you can see that is we have the chemical industry is using the utilization of the basic raw materials, having the heat exchange network and the separation and then reactor, and then it's produced all the materials. And then this is about the future. Probably you are familiar. I'm not sure that is more is mechanical engineers is maybe familiar with the industrial 4.0. Is actually industrial 4.0 is mainly is focusing on the smart manufacturing. Smart manufacturing is considered the broad concept, and then it is not something that is can be implemented in the production process directly. It is combination of the various technology and solutions that is collectively, and then is if implemented in the manufacturing ecosystem in terms of the smart manufacturing. So in the industrial 4.0 is commonly is the 9 technologies are is commonly is a show up. Is the one is the reality and then big data and then autonomous robotics and then manufacturing and simulation and system integration and cloud computing and then Internet of the Things and etc. So these are the main 9 technologies commonly is using for smart technology in the Industry 4.0. And as you can see, is the mainly is the important thing is nowadays is the we become the using the computers. So is the we are converting or just connecting the traditional hardware to the network, and then it's also it's the industry is the connect their machines and then also sensors and then their materials with the internet, and then is the controlled by different software and the systems. And then is the AI, as you know, is the AI is commonly is used in the manufacturing. So is now is converting now is between the human to the AI is controlling the manufacturing system. So is one example is the Hyundai is manufacturing is the built now is built in the Singapore, and then is previously is the manufacturing is controlled by the human beings. So it's manually is they actually operate the system, but it's now is they want to change all the AI system. So it's robotics they want to use, and then it's all the AI system is they actually the controlling the AI, so that is automatically is the all the AI is control the manufacturing, and then is all the processes. So that is the now is almost the human less the factory system. So this is very important, and then it's also is additive the manufacturing, and then it's a blockchain in the manufacturing and importance of the industrial robotics. So it's a robotics also is a very important part. Is in the future, and then it's benefit of the digital twins. So it's the next is I will talk about a little bit about the additive manufacturing. So it's when we talk about the manufacturing process, is the actually is we can consider it a 3 part. Is the one is the subtractive manufacturing, and then the second one is formative is manufacturing, and then the third one is the additive manufacturing. So this is one example. Is the subtractive manufacturing is actually is starting is this is a general overview about starting with the raw material, and then it's a cutting process, and then is we have the less the amount and then we have the final product is a chair and etc. However, and then through these processes we can actually having a lot of the waste. So this is the problem. And then for motives manufacturing is having the mold is one example, is the mold, and then is having the raw materials, either plastics or just the metals or any other materials that is actually is fairly, and then is made from the solidification, and then is after that is all the process is the final products. And then nowadays additive manufacturing is interesting. So that is additive manufacturing is defined as the process of the joining materials to make objective from the 3D model data, and then is defined by the layer as the opposite to subtractive manufacturing methodology, such as the traditional machining. So it's compared to the traditional method, like subtracting the methodology. The additive manufacturing is quite useful, especially for the high value products. So there is we have the three-dimensional model. We have the design, and then we program, and then we actually deposit layer by layer, and then at the end we can actually obtain the useful final product. So it's the advantage of the additive manufacturing is it can be automated and then toolless and then patternless, and then it's the freedom in design, and also is produce the functional part in the small production quantities, and then also is can produce the nearly tooling the quality part, and then also is material quality and properties close to the final products, and then it can be very short. And this advantage of the additive manufacturing is the high initial installation cost. So especially 3D printing is quite expensive. So actually the few million or just a few hundred also is the millions sometimes is based on the systems. And this continuous process, production process, and limited is component size. And this is the history, current development of the additive manufacturing. Actually, it's the 1986. Charles Poole was the inventor of the stereolithography or just 3D printing. The first patents from his idea, and then he actually did the supervised computers. And then it's the 1988, Charles Becker, actually the University of the Texas, and then filed the patents of the selective laser sintering technology. And then its feature is nowadays is known as the fuses deposition is modeling. And then next is the Scott Crump. Actually, he was developed the CAD materials, CAD tools. That is design the materials, and then nowadays is more is available, and then people are developing the 3D models on the computer. And then about 2008 in the first static the legs was printed. So we will see the later is a little bit more details. So the additive manufacturing is not only just chemicals, materials, or just polymers. Nowadays, also used for the medicine and biological applications. So these are some of the examples. On the right side, we can see some of the examples three-dimensional is printed biological perfusion reactors, and also is the bottom figures are showing the three-dimensional printed pharmaceutical tablets. So it's the nowadays is the AM process is in the advancing the field of the bioanalytics and biomedical and bioprintings. So it's a 3D printing technologies is actually fabricate these complex multi-component microfluidic devices used for the pharmaceutical industry, and also is the three-dimensional printing system is enabled to pharma is the kinetic profile of the candidate molecules, and then it's also is the now printing of the drugs can be possible, and then is the nowadays is developing the process of the scalable models for this technology. And then is the also is the during the actually inkjet printer can be also is used to develop the three-dimensional products. So and so on. So these are some of the examples for the biomedicine and biological applications. So as we can see the artificial the ear. So that is how we can the synthesis is the having the cell, as you can see, is a bee, and then is silicon, and then the silver nanoparticles is injected into the 3D printers, and then is mixing, and then combine, and then is actually is deposit layer by layer, and then is having the finally is three-dimensional is artificial the ear. So that is they can actually the test the hearing, and then it's also is the this material possibly is also is a make a three-dimensional is facial parts that is including the ears, and also is the nose, and also is the bones, and then is some other medical devices as well. So it's nowadays it's a three-dimensional the printer is technology is very important. And then it's this case is a three-dimensional bioprinting of the tissues and organs. So it's, as you know, is the tissues and organs is very important. Is once they are damaged, and then it's not able to the replace. So it's, actually the people are now is working on the actually in this area. So there is a three-dimensional printing of the materials, including the cells and the supporting, and then import the tissues is very important. And then is the three-dimensional bioprinting is applicable to degenerate the medicine to address the need of the tissues and organs. And then is the, however, is the three-dimensional printing bioprinting is very complex. So is we have to the best selection of the materials, and also cell, and then is the cell growth and differentiation factors, and etc. So actually is it require a lot of time to optimize the process and the materials, and then etc. And then is the three-dimensional bioprinting is the use for the generation of the and also transplantation of the several tissues, especially the skin, and also its bone, and then is also is the heart tissues and cartilage the structures and so on. So it's nowadays is this is some of the example. However, still need more time to actually to apply for the real the humans in the future. And then it's this is the actually the some examples that is showing that is a three-dimensional bioprinting of the tissues and organs. So that is first is the bioprinting is using the inkjet or just electro. So it's bioprinting and application is the one of the test bed, and then is the using for human part. Also is the micro actually extrusion and its implementation, and then is can be used the hollow materials, and then is the laser stick materials is can be used in the in vivo testing, and then it's also is using the especially kidney that is possibly is replace the kidney. And then it's also is a 3D materials can be used for the teaching materials, especially is the polymer is making the 3D materials. As you can see here is in terms of the they make the lumo and humo is the ethane, and then 1,3 the materials that is the develop the structures, and then is the showing the real material that is the how is the molecular structures are for the students in the class. So there is a student is when they look at only just the chemical name, molecular structures, and then is etc. Then is they are not able to understand that they are the real structure. But is when we develop the three-dimensional materials, then is we can show that is we have the same the molecular number